Okay, so good evening again, ladies and gentlemen. Moving on to some things in quadratic equations. It's still algebra, which is fairly simple. We know about substitution, we know about substitution, transposition, factorization, right? Which are the main points that we use in algebra, right? They're these are quote unquote abstract thoughts or ideologies, but really and truly it's just reasoning and using your imagination, all right? Really and truly, that's all it is. All right, so it says on the grid provided, plot the four remaining points of the graph, right? X squared plus x minus 4, where x is less than or equal to 4, and x is greater than or equal to 4, but less than or equal to 3, which is all the values that we are given here, right? So this is the range of values for x, and we are going to use each value of x, put it into the equation, x squared plus, put it into the equation, x squared plus x minus 4, right? And then we will get a y value, right? Quick example, I guess. This is not the answer to the question. This is just a quick example of how we use it. We call it a function. Some people might call it a function machine, right? So it says that y is equal to x squared minus 4, and we're going to say let x be equal to negative 4, right? Then y would be equal to negative 4 squared, right? Y is equal to negative 4 squared because x is equal to negative 4 plus negative 4 minus 4, right? Negative 4 squared so negative 4 squared is negative 4 times negative 4, that's equal to 16, plus negative 4, that's minus 4 minus 4 more. And of course, we know that 16, we know that 16 minus, well, we're subtracting 4 2 times, so that's what, minus 8. So y is equal to 8, which is the value that they have here. So for each of the values that they have here, all they did is they used the same formula and they use different values of x. Okay? They use the same formula but different values of x. Okay. We clear?
Yes, sir.
Yes, sir.
Okay. All right. So let me just make a note of all the values of y. So y, well, let's use x and y. So x equal to, so the values of x are negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. Those are the values of x. The values of y are 8, 2, minus 2, minus 4, minus 4, minus 2, and minus 4, minus 4, minus 2, and 8. Yes. All right, so those are the values that we are, those are the values that we're working with.
Yeah, you miss your value for why.
Sir, you have one more 2 beside the -2.
Repeat that.
Sir, you're supposed to have one more 2 after the -2.
Oh, yes, thank you.
Sir, we are not hearing what you're saying. Sir, if you're talking, yes, we're not hearing you.
All right, so for the online group, so we want to plot these points. So at 0, when x is equal to 0, this is equal to -4. That's right there, about. When x equal to -1, that's negative. When x is -1, y is -2. That's about right there. When x is 2, y is 2. And when x is 3, y is 8, which is somewhere all the way up there. So we're not going to, I'm not going to try to draw that. Okay. All right. It asks us for the lowest point, but we can't draw the lowest point until we have finished drawing the curve. So we're going to freehand this and try to draw as smooth a curve as possible. As smooth a curve as possible. Okay, that's as smooth as I can get the curve. Okay. And based on what we have here on the curve, we can see that this part, let me highlight that let me highlight that in green. This part here in green, that would be our lowest point, yeah, which reads approximately that reads approximately what? Let me just write it here. So lowest point, point, it reads approximately a half on the x, right? So the x value is approximately 0.5 on the x-axis, and on the y-axis it's about 4.2. That's about it. They will give you, because each person draws the graph a little differently, right? They won't kill you if your answer is off by 1 or 2 decimals, right? They won't kill you if it's off by.
Excuse me, sir, I have a question. Sir, so the lowest point, sir, of it, sir, would it be the center of the, when after you draw the line, sir, it would be center?
Yeah. Imagine you have a perfect curve. The lowest or highest point would be the lowest point of the curvature would be the lowest point of the graph. Make sense?
Yes, sir. Sir, so the highest point, sir, would be the top, sir, or it would be the same as here,
Well,
sir,
they
but
have
only different
no,
measurements.
for this part, we have no top. There's no top right here. Yeah. So
Sir, he's asking if we have a highest point, like we have a lowest point if we have a highest point.
we will have a highest point if the curve was in a different, if the curve went in a different direction. If the curve went in this direction, the curve went in this direction in blue, we would have a highest point. Okay. Otherwise,
Okay, sir.
yeah. Only if the curve goes in this direction would we have a highest point. Okay.
Sir,
Listening?
there's somebody commented that if you like how you have, like how it's at -4, sir, if it wouldn't be -4.2.
Yes, it would. Thank you for catching that. I was hoping. Woo. Right? Sometimes you have to make these mistakes on purpose so that people can see them alone. We don't want to think, hey, just because the number is below the axis, that the signs don't matter. Signs matter. Okay? The sign does matter. All right. Think of, well, I'm going to give you guys 20 seconds. 20 seconds to look up what we mean by line of symmetry, and then I want you to come back and tell me where do you think the point of where you think the line of symmetry would be for this graph. So we had just finished the previous question, and now we're looking at this circle theorems question. In red, we have the angles that we're supposed to be looking for. Let's highlight those. They want angle ECD. So we're going to start at E, go up to C, and then off to D. That looks to be this angle here. That is angle ECD. They want angle CFG. Yes. Start at C, go off to F, and then up to G. So that's this angle here. and they want angle CGF from C to G, and then from G to F. That is all of this angle right here. Now, while I don't mind finding just these three angles, right? I'm going to use some old-time wisdom and just find everything first, right? Which is what my teachers and my father told me, right? Just find the answer to all the questions first, and then give them the ones that they want. Okay, so let's try that. So we also have angle AEB. Sorry, line AEB. That is parallel to line CFD. So we have two parallel lines, and we have several transverse lines. Okay, so AEB is parallel to CD, so we have some parallel lines there. So we can use that to our advantage. Okay, we know that angles on a straight line add up to what?
180.
180 degrees.
180. So if this is 106, that means that the rest of it is what? This is what? 74 degrees right here? This
Yes,
part
sir.
is 74.
Yes, sir.
Yes.
Yeah, good. We can see that this is a Z angle. Let's highlight the Z angle here. So we highlight it in I don't know what can do. Blue, green, light green. Light green works. Here's a Z angle. 1, 2, 3. All right, so that's a nice Z angle there. And we have also found, you know, whether by accident or by design, we have found angle FCG, or sorry, it says ECD, right? Z angles are equal. If Z angles is a new term for you, you might hear alternate interior angles are equal. So this is equal to 68 degrees because we have to give our reason, because Z angles, I like saying Z angles. Z angles are equal. Of course, you can use alternate interior angles. That's the preferred term to use. Alternate interior angles. I don't think they should fault us for saying Z angle. For saying Z angles, though. All right. Let's see if we can. So this is 74. Do we have any more Z angles? Let me put the 68. All right, sorry, that's so bad. Just give me a second, ladies and gentlemen. Apologies. All right. So that is 68 degrees. We need angle CF G as well, from C to F, and then from F to G. Well, let's see what we can do here. We know that there are angles. We see that GOE, if we turn or if we kind of tilt our heads to the left a little. To the left. Yeah. You can see that GOE is a diameter, and the diameter cuts the circle into two hemispheres. And we know that angles in a semicircle add up to 90
degrees.
Right, good. So that means that all of this is 90. All of this would be 90. But a piece of this 90 is 74. So what's the rest of it?
So that would be 16 degrees.
16. So angle CFG is equal to 16 degrees. Why? Angles in a semicircle. So that is 16 degrees. We could also do the same with the other side. It's not one way. It's not one way to quote unquote skin a cat. It's not one way to skin a cat. We pay attention to all the different ways. So if this is, so that part is 16, this part is 90 minus 68. 90 minus 68 is what?
22 degrees.
22. So this part is 22 degrees. Apologies for my bad handwriting. And then we are sure to be able to calculate angle CGF. Give me your answer and your reasons why.
Sir.
Yes.
It is CFG, sir. So, sir, me want to know if you're something. All right. So your minus, so you do 106 minus the 74, sir. That's the one after you get 32 and show one semi circle. You minus it, you divide it by 2, sir, and get to 16. What that do?
No. Because this is angles on a straight line right here. I say 180 minus 106 gives me 74. Right. And then we see that line GOE is making a semicircle. Angles in a semicircle add up to 90. So this whole entire angle would have been 90, but piece of it is 74. That means the next piece of it must be 16.
Okay, so it is minus 90 from 74.
70, yeah, subtract the 74 from the 90, get the 16. I did the same thing on the other side to get the 22. And now I have a triangle. Oops, gave away a piece of the answer there. And now you're supposed to find the rest of the question, which is angle CGF. Let me highlight it for you. Angle C to G, from C to G, and from G to F. All right?
All right. Yes, sir.
All right, so give me that answer and tell me your reason.
Therefore, my answer is I got 38 degrees.
So you want us to find CGF, right?
Repeat.
You want us to find CGF, right?
Yes, I do.
Sir, I think I got 68 for that one.
68.
Well, let me check.
All right.
So I got 38 degrees.
We got 38 for CGF up here. So this one up here.
So I can't respond because and this is the first time you learn this.
Sir,
Sorry, I'm listening. Yeah, so I'm just highlighting where CGF is.
sir, is it 142?
That's what I got too.
Why do you say it's 148?
So
142, sir.
142.
Yeah.
Why is it that?
So-
Sorry, was 142, yeah?
Yeah, so I added the 16 and 22. And then since angles in a triangle are equal to 180, I subtracted the sum of the two numbers, which was 32, I think. And then subtracted it, and I got 142.
And you would be most correct. You would be most correct. All right. So that angle there would be equal to 142 because the angles in a triangle sum to 180 degrees. All right. Is it the only way to work it out? No, but it's a very good way to work it out. All right. There's also angles in a cyclic quadrilateral that we could use. Right. There's I think there's at least one other method. All right, but we leave it there for today, for tonight, ladies and gentlemen. Thank you very much for coming and passing through. All right, look up if you're not sure how to answer the questions. Please to look up the circle theorem, the different theorems of circle theorem. All right, and try to apply them in the question as you go along. All right, thank you very much for attending. I'll see you guys next time.
Bye, sir.